Hey there, everybody. Welcome to my forensic tool demo for ITEC 4322. And today we're going to be taking a look at volatility. Volatility framework is a completely open collection of tools that is used for forensic investigations. It's implemented in Python and is used for the extraction of digital artifacts from volatile memory or RAM samples. So first, let's take a look at how we would install volatility. I'm using Kali Linux, and as I said before, it can be used on any system that's already running Python. In Kali, it's easy to install from the apt repositories, and we would do that. So install volatility. And I already have it installed here. That's the command you would run. Go ahead and tell it yes, and it will be installed. We can first take a look at the help file. And just make sure it was installed correctly, and kind of see some of the different options and usage. So we'll take a little bit closer look at this as we go. But the big thing are all these supported plugins that really make looking through this information and pulling out what you want to know much easier to do. So first, let's once you have obtained a memory dump, in this case I have a sample memory dump already that we'll start looking through, and we'll do that using some of these basic commands. First thing we might want to do is see what information volatility can give us about the image. So we'll call volatility, and we'll say the file we want to look at is laptop.img, and we'll use the image info plugin, and it's going to run a search and compare it and give its best guess as to where this image was running on. And so in this case, its suggested profile is Windows XP, there's Service Pack 2 or Service Pack 3. And in some cases, you may have a lot broader range where it's not as sure. And so you may have to run all these commands with specifying which profile you want it to run. In this case, it's going to run everything as Service Pack 2 of Windows XP. We can see different information, including when this image was taken and number of processors, things like that. So now let's go ahead and see what else we can find out. Let's take a look and see if we can view the processes that we're running in memory. So for that, we're going to use same command for a lot of this, calling volatility, choosing the file name, and then changing the plugin. So let's go ahead and look at a process list. And so we get a lot of information here. And this is a relatively small image, so it's pretty limited. You may have a lot more if you took one of your system. And kind of look through and see if anything looks out of the ordinary. See what's running, process ID, and stuff that's been closed out. That's a good place to start. You can also view this same info in a tree, which just kind of shows how some of these processes are related, and pretty much gives about the same information, time these processes started. and what's running under system, along with the specific offset of where these are in memory. Again, we can look through and see if anything stands out, something we don't recognize, something we want to look into further. Let's take a look at another one that kind of puts a lot of this info side by side, SVC scan. And that'll show us some of the services that were running, the binary path, how they were started. It was manually, automatic, auto start. So you can browse through that and see kind of what was going on. We can take a look at any command line history that may be available. And we'll just run command scan, CMD scan. And so we're able to see the inputs as they were put into memory and see that it was a data dump DD command of the input. So actually when this image, RAM image, was created, and that's really all that's on this image. Another image may have quite a bit more information to be sorted through. Another interesting thing that can be examined is something called shell bags. Shell bags kind of help track views, sizes, and positions of a folder window when it's viewed through the Windows Explorer. It's become a popular method of kind of determining what was going on the system, what areas the suspect might have been accessing, and also seeing information found in shell bags could show folders that may have been deleted by the time the machine was obtained and examined. So we look at that using shell bags plugin. And we can see modified times, file names, access dates, more plain text, and then some, folders that may have been browsed through. Something else I'm noticing we haven't seen yet, kind of seeing a username possibly, which could, be confirming what we suspected, that this was the user we're looking for, or maybe that's something we didn't know about and need to look into more. We can take a look at some network connections. There's a couple different ones, connections and ConScan. We could, again, it shows the offset and some different IP addresses that can be used to confirm some activity or point you in the direction of some activity you need to look into, as well as what process ID that may be associated with. So you can dig into that a little bit further. Nice thing about the volatility command line is you're able to pipe to other commands. So for example, we just looked at ConScan. So they were pretty interested in that 1916 PID. We only want to see what's going on there. So what we can do is take that command and pipe it just to a simple grep for 1916. And we can see that just isolate that traffic for a little easier analysis. Since we're kind of looking at wondering about users, let's take a look and see if we can get a hash dump of the users on this system. And here we go, we see Sarah, as well as the others that look like they're pretty much just built-in profiles. Then we can do the same thing. We can pipe that to grep for Sarah and only see that user's information, which we then could use to try and crack that hash and gain access to the system, or unlock something that we needed to get into. So another view that lets you kind of see what it does, it enumerates all the processes with a that shows all the different methods that you're able to look at it. So this is a good command if you're looking for malware or a rootkit. And so it's going to show you all these different names and whether it's visible in PS list, PS scan, thread process, and so on. So all these that are, showing true, you could see when logon in all of those. When you start seeing some being false when they have not been exited, you maybe begin to wonder if that's suspicious, that it's something that's trying to be hidden and could, possibly be malware or something going on, and can look into it further. So say you did find something that looks suspicious and it, could be malware, and you need to kind of examine it in a little different setting, do some reverse engineering and see what specifically is going on. You can dump DLLs from volatility for this type of analysis. In this case, we'll call DLL dump, and we need an offset. So that'd be the offset of this specific and suspicious process ID. And then we specify the dump directory folder where we want that information to go. And so this kind of looked suspicious. We weren't sure what was going on. And so we were able to select that offset and dump all the DLLs out of it. And if we look in the dump folder, we can see all those DLLs were dumped out and can be examined. The final thing we'll take a look at, which really is only scratching the surface, but hopefully this kind of gives you a good idea of how in-depth and how much information is available from something, seemingly as simple as, just the RAM on a system, of what kind of information you can find. We can kind of try and see if we can see any internet browsing history. So let's do a process list, view, and search for Internet Explorer. And so there's one PID of 2392 associated with Internet Explorer. And so there's a built-in plugin called Yaroscan, which basically does regular expression searching. And so we can do a basic search using that process ID that we just saw, 2392. with the regular expression. And so we get a dump where we can see, there was some Windows Update traffic, it looks like, Windows Update. Something Spybot. It's kind of interesting. But using that plugin with regular expression strings, you can go through and find browsing history and search for a little more specific things that you may want to look into. So other than that, we can look at the help file one last time and kind of just see how, we really only scratched the surface. And how each of these can provide, significant information during a investigation as to what was going on this system at the time that this image was obtained. Alrighty, thanks for watching.